What's up, you guys? Rex here. So I just finished my fourth and final week learning about the brain in medical school. So I just want to take this time to really reflect on how freaking cool the brain is. So the way that the brain is presented at my school, Duke University, is kind of interesting. Our main professor, he actually has a course on Coursera where he has basically taught everything he wants to teach us. So we sort of take that course and then have application sessions where we talk about it. It makes me chuckle every time, but this professor emphasizes one of his key principles of medical neuroscience at the beginning of every lecture video, talking about how the brain is the body's most complex organ. And I think there's a reason he emphasizes it. This man loves the brain more than any other person I've ever met loves an object, and I absolutely love his passion for it. And it really is true that the brain is the body's most complex organ. And so I want to take a moment and hopefully convey to you how amazing the brain is. So the first thing that I found absolutely incredible is talking about how the brain actually develops. And so we talked about how there is a very significant genetic basis for how the cells and circuitry in our brain is developed. And there's also a very significant environmental influence. And this can be both like a pathological influence, but also how we normally interact with the environment has positive influence on how our brain develops. But these two factors together, sort of that nature, the genetics, and nurture, the environment, aren't enough to describe how the brain develops. And there actually is this sort of idea of self-organization, that the brain actually self-organizes based on itself. And this, a lot of it has to do with electrical activity happening in the brain, and where the brain naturally develops electrical circuits, and these encourage other things to change. And it's not that it's inducing different gene transcription, but this is happening above the level of gene transcription, and it's not a genetic influence, but it still is impacting how the brain develops. And so there's examples of this in our vision, where even if we never see light and it happens before we ever see light, we do develop some neural circuitry that is related to how we process vision. And this isn't something that is based on gene transcription, but it's just based on the patterns of activity that naturally occur in our brain that encourage this self-organization to be able to process our visual stimuli in a specific way when we start seeing vision. And now it's really interesting. Some of these pathways can develop without any sign of light, but they can actually be caused to develop incorrectly or develop worse than if there had been zero light. And so an example of an experiment of this is you can raise lab rats in total darkness so they never see light, and their visual circuitry in this one part that you can study actually develops relatively normally. But if you actually have it so the rat's eyes are completely shut, but they still are seeing light, so they're getting some light through their eyelids, this can actually cause these circuitries in the brain to maladaptively develop. And so there's this interplay between environmental factors, the genetics that is starting it all, and this self-organization, that they're all not working independently, but rather they're bouncing off each other and impacting each other and feeding off of each other to help the brain develop. But the key thing that's most amazing is there is this actual force of self-organization in our brain that is crucial for our brains to develop into the fully functional, incredibly complicated organ that they are. Another thing that I think is absolutely incredible about the brain that is really sort of unique compared to other organs is how our thoughts and behaviors can actually impact real biochemical processes. And so an example of this is that there is a lot of literature and huge studies on all the different changes that occur biochemically in the brain of someone suffering from depression. And it absolutely just boggles my mind when I think about it, that in some patients, you can actually treat their depression with cognitive behavioral therapy, et cetera, et cetera. You also can treat it very effectively with pharmaceuticals. But the idea that something that is fundamentally related to sitting down and talking to someone and thinking through thoughts, that just that act of thinking and communicating with another person in a specific way under the guidance of a trained clinical psychologist or counselor can lead to real biochemical changes in the circuitry of our brain. And that's something that really is different. Like if you have kidney disease, you can't just talk to someone about how their kidney's working and that's going to make their kidney function in a less pathological way. But that is the case for some conditions in the brain. There is this connection between the thoughts and actions and choices and conversations we have and potentially treating pathological conditions in the brain. That just blows my mind. Similarly, it's absolutely amazing to me how we can use diagnostic tests to determine where there potentially might be lesions in the brain that are causing pathology. And so an example of this is like the Iowa gambling test. And just really quick, it's basically there's 4 different decks, and the goal is to get as much money as you can. Some of the decks, you draw cards and you win money. Sometimes you lose money, and it varies how often you win and how much, and how often you lose and how much. And someone who has neurotypical anatomy can pretty quickly figure out what are the 2 correct decks, so to speak, that are good based on game theory to net make you gain money, and which are the 2 decks that net will make you lose money. And depending if there is a lesion in the prefrontal cortex or if there's a lesion in the amygdala, some patients will, rather than ever discover which are the 2 ideal decks, they will continuously draw from the decks that are net losses. And it's just incredible to me that we can make these connections between a region of the brain and then diagnose it based on a game of cards. That's also like, back to the kidney. If someone has a kidney disease, you can't just ask them, hey, let's play a card game and we'll use that to diagnose what type of kidney disease you have and what's going on at a cellular level. The fact that we can actually connect processes at a cellular level up to playing a card game with pretty high consistency and accuracy is incredible to me. And the last thing I want to just talk about with like the complexity of the brain is that obviously I really don't know much in the grand scheme of things. And there's a huge amount of unconscious ignorance that I have about basically every organ system we've covered. But I do get the general idea that we have a pretty good understanding of how the heart works and how our kidneys work. And so maybe we know 50% of what there is to know about the heart. Maybe we know 90% of what there is to possibly know about the heart. But learning about the brain, this is really something that we are just scratching the surface. And so I don't know if we know like 1% of how things work. I have no idea how big that level of ignorance there is that we do not yet know. I don't know what I don't know. But I get the impression for the brain that we are a long way from really figuring out how the brain works. So it's been really cool to see my classmates ask questions and to be able to ask questions myself and have the professor, who is incredibly knowledgeable in basically every area of the brain, be like, yeah, we haven't figured that out yet, but we're slowly getting there and maybe we'll get there someday. And so there is a huge like frontier in knowledge that exists in studying the brain that makes it really fun and fascinating to study. So I can't wait to learn more, hopefully in my medical journey, but also maybe 20 years from now, learn something cool and continue to learn something cool about how the human brain works, the body's most complex organ. If you want to catch more of my videos, either reflecting on my journey or sharing things I learned in my journey to become a doctor, make sure you subscribe, hit the notification bell. If you have any questions, comments, or concerns, drop them down below. I'll read and respond to every single comment. As always, like the video if you like the video, dislike the video if you dislike the video, and until next time, don't be ordinary, go be great.